Today we're going to focus on rational numbers, specifically rate and ratio. This is section 5.1 and 5.2. Rational numbers are numbers that can be written as a fraction. The word rational comes from the term ratio. Ratio is a comparison of two quantities by division. So this is focusing on our fraction. Positive rational numbers are ratios expressed as a fraction whose numerator is a whole number and the denominator is a natural number. And I'll show you a picture of what that means. Every whole number, this is important, is a rational number. Now, improper fractions and mixed numbers are also rational numbers. As you can see in the illustration, it divides real numbers into two parts, rational numbers and irrational numbers. Now, rational numbers are any number that can be identified as a fraction or decimal. These are going to include, can include whole numbers, they can include positive, negative numbers, these can include any natural number, but the focus here is rational numbers are going to be identified as some fraction or decimal. Now, irrational numbers, irrational is opposite of rational, and what irrational numbers are going to be anything that can't be turned into a normal fraction. So if you look at the illustration here, it's going to be square root of 2 or square root of 3, square root of 10. It can't be identified as a basic fraction, or it's going to be a decimal that is going to be a non-repeating decimal. If you look in and on the left circle, you do have decimals that are repeated. Okay, 9.454545. Okay, that is a rational number. But the focus is if it's going to be repeating forever, that would be irrational. Now we have 3.4, it ends. So that's going to be a basic fraction. But a repeating number that goes on and on forever would be irrational, like pi. Pi is 3. Hey, why are you crying? I'm trying to do a video. Why are you crying, baby? I'm trying to do a video. So any number that goes on forever, specifically a non-repeating number, some random number, that would be an irrational number. So if it can be a fraction, a whole number, a positive, negative whole number, like an integer, if it can be a decimal that stops, whether it's positive or negative, those are going to be rational numbers. But if a number goes on forever, if a number is going to be non-repeating, just random, or if it's a square root that cannot be simplified or turned into a whole number, that would be an irrational number. Okay, this example, I want you to express each of the following as a reduced rational form. So 14 would be 14 over 1. Okay, 8 and 3/5, we're going to multiply 5 times 8, that's 40 plus 3, 43 and 5th. And then 35 and 95, I can find the least common multiple, and I can find a factor that they both go into, and that's 7. I can kind of cross cancel here, and I'm left with 5 over 13. Now, rational numbers under square roots. When a rational number is under a square root symbol, it can be simplified by taking the square root of the numerator over the square root of the denominator. So instead of square root of n over n, I can also do square root of m over square root of n. Okay, here's some examples. Here's square root of 1 over 4, which would be square root of 1 over square root of 4. Now the square root of 4 is 2, so if we simplify the square root of 1/4, we would get half. Because the square root of 1 is 1 and the square root of 4 is 2. Now here's another example. Square root of 25 over square root of 144. and square root of 25 is 5, and then the square root of 144 is 12. So that's how we would simplify. Here's some practice problems I'd like you to try. Can you simplify? Okay, go ahead, pause this, and then you can press play and I'll show you the answers. Okay, you can go ahead and check your answers. Remember, I can simplify 10 over 4 to 5 over 2. Okay, both go, 2 goes into both of those. 0 would be just 0 over 1. I can do 11 times 6 equals 66 plus 5. Now I get into the square roots. Square root of 36 is 6, or 6 over 1. Now here, we're getting into our practice problems. Square root of 4 over square root of 64, and the square root of 4 is 2. The square root of 64 is 8, but then I can simplify 2 over 8 into 1 over 4. Then I have square root of 100 over square root of 9, and the square root of 100 is 10, and the square root of 9 is 3. I can't simplify anymore, so 10 over 3. Okay, simplifying rational numbers. Now here are some examples. 4 over 5 cubed, that means I'm doing 4 over 5 3 times. So 4 times 4 times 4 is 64, 5 times 5 times 5 is 125. Okay, so that's stuff we've already used about exponents, very basic, very easy. And then we have 3 times 5 over 12, and what we can do is 3, that can be like 3 over 1, so I can cross cancel, and that would give me 5 over 4, and then I do the square root of 64 and 121, and that would give me 8 over 11. Okay, so I have 5 over 4 plus 8 over 11. I have to find my least common denominator, and then if I do my work, it's going to be 44, and so 4 times 11 is 44, so I have to do 5 times 11, that's going to be 55. I'm going to do the same for 8 over 11 to get 44, and then I'm going to multiply 8 times 4 is 32. And then my answer, 55 plus 32, is 87 over 44, and then I can turn that into a mixed number. In the same way, I'm going to divide first, and remember, if I'm dividing fractions, I can just turn the 6 over 5 into a reciprocal, and that's going to be 15 times 5 and 11 times 6. So 61 over 44 minus 25 over 22, I have to find my least common denominator, and that's going to be 44. And so 61 over 44 is going to stay the same. The 44, however, will need to be or 22 needs to be multiplied by 2, and then 25 by 2. Then I have 11 over 44, and then I'm going to simplify that to 1 over 4. Now, rational numbers versus irrational numbers. The addition or multiplication of rational numbers always result in a rational number. Rational numbers are not closed under a square root. That means there can be a square root. So square root of 36 would yield 6. So there's an equivalent, there would be a simplified form. So an irrational number would not have a simplified form. It would have to stay a square root. So if it's not a perfect square, it would be irrational. Now, ratios. The numbers in ratios are called terms. Ratios can be expressed in lowest terms, and so this is a comparison between two things. So a soccer team won 10 games and lost 6 games. So the ratio of wins to losses would be 10 wins to 6 losses. So 10 to 6, and we use that little colon to represent the ratio, 10 to 6. Or we can do a fraction, 10 over 6 is the same thing as saying 10 to 6. So as you can see in example 2, I can identify a ratio 3 different ways. I can do the number square root of 3 over, using the division bar, over 2. So I'm going to compare the square root of 3 to the number 2. Or I can just say square root of 3 to the number 2. Or I can use the colon, square root of 3 to the actual number 2. Here's another example. Find the ratio of Midianites to Israelites in the final battle. So there's 135,000 Midianites to 300 Israelites. I can simplify this by finding the greatest common factor, and that's going to be 300. So I can divide 135,000 into 300, or 300 into 135,000 to get 450. So we know 300 goes into 300, and we get 1. So the ratio is 450 Midianites to 1 Israelite. So that's going to be the ratio simplified. I'm going to have you go ahead and express each of these numbers in a reduced rational form. I'm going to go ahead and have you pause this, go ahead, try and write these out, and then you can press play again. And I'll give you the answers. Okay, so 8 to 12, I can simplify this, so reduced rational form. 4 goes into both of those. 2 times 4 is 8. 3 times 4 is 12. So the 8 to 12 would be reduced to 2 to 3. 18 to 19, I can reduce this. 9 goes into both, so I can do 2 to 1. Ratio is 2 to 1. And then 50 to 60, I can go ahead and simplify this to 5 to 6. I can simplify by having 10 go into each of these, so 5 to 6. Okay, take a look at practice number 2. If there's 14 girls to 10 boys in 7th grade, go ahead and express each ratio in lowest terms. So we know it's 14 to 10, but I can simplify. And so if I focus on boys to girls, it would be 10 boys to 14 girls. And I can go ahead and I know the greatest common factor, I can divide by 2. Well, is there something else I can divide? I know 2 times 5 is 10, and 2 times 7 is 14. So it would probably be, for boys, it would be 5 to 7 girls, 5 boys to 7 girls. For girls, I just flip it. It would be 7 girls to 5 boys. And then boys to students, we know 10 boys, okay? And then for total students, that's 24. So I can go ahead and identify 10 to 24 if I divide into 2. So that would be 5 to 12. So let's take a look if we did that correctly. Okay, so we got 5 boys to 7 girls, 5 to 7, or 5 over 7. Okay, 7 girls to 5 boys. And then boys to students, we know it's 10 to 24. I can divide by 2, so that would be reduced to 5 to 12, or 5 over 12. Okay, you can find the equivalent ratios by multiplying both terms of the ratio by the same non-zero number. You can also do this by dividing. So basically what we have here is if I have 2 over 5, or 2 to 5, I can multiply that, okay, by the same number to get a larger number. So if I multiply by the 2 by 3, I have to multiply the 5 by 3, and that would give me 6 over 15, or 6 to 15. I can do it the same way in dividing, and that could give me that same ratio. Now, if I talk about unit rate is a ratio that compares a quantity to 1. So one great example is 68 miles to 1 hour. If you ever heard of you're driving 55 miles per hour, that's what we're saying here. 55 miles per hour means per 1 hour. I'm relating this to something that is 1. So 55 miles per 1 hour. That will be a unit rate anytime I compare it to 1.